Okay, the next thing we're going to talk about is what happens after we graph our data. We can actually describe what's going on with our graph by describing the shape of the graph. So we have some key terms we use to describe the shape of a graph. Our first one is symmetrical. So symmetrical is usually single peaked, and it looks like a mound, and both sides spread out to be about the same distance from that mode or peak. And so that may look like something like this. That would be our symmetrical. Now, something else with symmetrical is that our mode tends to be approximately equal to our mean, which means it'll be approximately equal to our median. So when we get this occurring, that's gonna, using that that measure of center can help us determine that it's actually pretty symmetrical. Now, not always, because we still need to look at the shape of it, but it gives us a hint into that. So our next one is what we call right skewed. Now, this distribution has a peak, or a majority of our values to the left-hand side, and a tail that goes to the right. So it's called right skew because our tail goes to the right. So this is going to look something like this. Kind of peek out like this. So this is our tail. And when this occurs, we're going to talk later what happens with our mean, median, and mode. But we're going to find that our mode tends to be a smaller value than most of our other values. Our next one is left skewed. So left skewed is going to go the other direction. And so it will look like this. So our tail. So our peak's over here and our tail's over here. And because the tail's on the left-hand side, that's why it's called left skewed. Now, our very last one is called a uniform distribution. And we don't see it all that often, but every once in a while we will. And that usually means it has no major peaks, or it's just really pretty flat. So something like that, or it may peak a little here and then peak a little, but really, overall, it kind of looks flat. And so then a lot of people say, well, you're kind of drawing these curves. But nothing that we've graphed was really a curve. We've had histograms, we've had dot plots, we've had box plots. How do I know what that curve is going to look like, or that shape's going to look like? And so I'm going to show you that. What we're doing is we're doing kind of a sketch of a density curve. So here's a dot plot, and so when I kind of just draw a line above it, and just kind of sketching what we call a density curve where all the dots are below that. Actually, that's not a very good curve. So let's look. And so you look at this and it looks pretty symmetric. This side is a little bit longer than this one, but not by much. And so I would call this symmetric. And so you can see over here, this is exact same graph, but as a histogram. So you can kind of see that by graphing this, we can kind of tell, wow, that looks like a much better symmetrical round. And so it's much better. For a box plot, we can't really draw a curve because it's a box. So what we kind of do is we kind of look at, well, let's look at these distances, and hey, are they pretty much the same? If they're pretty much the same, we would call this symmetric. So what I'm going to ask you to do is I'm going to ask you to look at these and decide, are they symmetric? Are they right skewed? Are they left skewed? Just kind of give your best guess on that. So here's another sample. And this time we've got 50 11th graders. And this is data based on their score from the memory game. So as we look at this, we get kind of this, and then it tails out. Not much of a peak here based on this, but I definitely see a tail on this side. And then as we look over here at the exact same data, but as a histogram, we could see, oh, yep, definitely more of a peak and definitely more of a tail. And then as we can look here, as I look at this, compared to, oh, looks like I have some outliers right here, graphed. I could definitely see that I see a longer portion here, and the longer portion is going to be my tail. And so that means that there's more data boxed up here. This is where my peak will be occurring. And this is when it's longer, that means there's less data there, and there's my tail. And so this tail is definitely on the right-hand side, so this is a right-skewed distribution. The shape is right skew. And so then our next one, again, kind of giving us the same idea as I draw this. Oh, yep, definitely a tail over here. And when I look over here, histogram also kind of giving me the same data. And here's a tail. More data's on this side, less data on this side. And so this is a left skew distribution. And so this is what I'm going to be asking you to do, is look at it and kind of tell what's going on, what is the shape of this distribution. Once we know the shape, that can tell us some more information. So how do you know which measure of center is the best one to use? Because we don't want to have to calculate all three every time. Why calculate the mean if we don't have to? And so what we learn in statistics is that if you have a skewed distribution, you're going to use the median. If it's symmetric or uniform, you're going to use the mean. So now we're going to go ahead and use this idea of what's my shape, and then so what center should I use? So when I'm looking at my stem plot on sample D, what's a good idea is to think of this as the bottom, and this is the left. So this kind of needs to get turned. So let me take a picture of this. And let's turn this so we get an idea of how we're going to turn our paper to look at it. So here's that same picture, and I'm going to turn it. And I'm going to turn it so it looks like this. And I turn it so my smaller numbers are on this side, because the number line should go from small to large. So I turn it like that, and I look at the distribution. So now when I'm looking at this shape, I'm looking at, peaks, and then here's my tail. So this is definitely a right skewed distribution. And since it's skewed, we're going to use a median as our measure of center. So now we don't have to calculate all three measures. Median is the most appropriate measure. So now we're going to do the same thing for our next box plot. Stem plot, sorry. So I'm going to go ahead, I'm going to take a picture again. And we're going to go ahead and, where'd that one go? Oh, there it is. So we're going to turn that around. So smaller numbers to bigger numbers. And we're going to take a look at the shape of that. And so when we look at this, let's grab a different color. You know, there's more data on this side, but really overall there seems to be an even amount of distance. So I would say this is symmetric, which means we would use the mean as our measure of center. Now the only caveat or the change to this is if we have an outlier. If it looks like we have an outlier, we would check to see, do we have an outlier? And if we have an outlier, even though it's symmetric, we would always use a median. But that's not something that we're really going to get into until you take an upper level math class. Okay, and our last thing is how does the tail affect the mean? So the reason why we don't like using the mean with skewed data is because the tail pulls the mean in the same direction as the tail. So the mean all of a sudden isn't accurate anymore. And so in a right skewed distribution, the mean is larger than the median because the mean is towards the right-hand side, which is the larger numbers. Now in a left skewed distribution, the median is larger than the mean. And that's because the mean is being pulled to the left or towards the lower numbers. And then in a symmetric distribution, the mean and median are approximately the same. And again, this only occurs when there's no outliers. So we use this as kind of a general rule of thumb to figure out what's happening to the distribution. So sample F, the mean of a distribution is 14.1 years, and the median is 17 years. What is the shape of the distribution? So let's think about our number line. If we've got 14 and 17, this is our mean. and this is our median, we know that the tail pulls our mean. So that means our tail is going to be over here, tail, and the bulk of our data is going to be somewhere in between them. And so what that means is that because my mean is farther away from my median, they're not the same, my tail is pulling it this direction on the left-hand side, so this is a left skewed distribution. Now on our next one, the mean of a distribution is 170.5 and the median is 120. So when we look at our number line, we've got 120, we've got 170, and this one is our mean, where this one's our median. That means that my tail is going to be near the mean. So I'm going to have the tail near the mean, and then we're going to peak somewhere in between them. And so if my tail's over here, it's going to be a right skew distribution. And that's what we're going to be working on in class.